So now that we've established what absolute value is, that is refers to the positive value. So now what we want to look at is the absolute value of graphs. How does the absolute value of a graph occur? So to graph an absolute value of the function, make a table of values and graph the function. All right. Another way to do it is to graph the original function, whatever's in the brackets first, and then change it to the absolute value. Okay, so I'll explain that whole page by doing basically the first graph on page 286. All right, so it says graph an absolute value of the function in the form y equals the absolute value of ax plus b. So consider the absolute value of the function y equals the absolute value of 3x subtract 1. So I have y equals absolute value of 3x minus 1. Okay, so the first way in which you could do this is to plug in coordinates for x and solve for y, the same way you would always do it. But what I want to do is I'm going to graph what's inside the absolute value first, and then I'm going to take the absolute value of it. Now I'm going to do that because when I do reciprocal functions later on in this unit, or the next unit, okay, is I'm going to graph the original first, and then I'm going to reciprocate all of the y values after that. So this is what it looks like. I have a line in which my y-intercept is what? What's my y-intercept of that line?
3x with 9.
What's the y-intercept of my line? What is it? What's that? Y equals mx plus b. So what's the y-intercept? -1. There's my starting point. 0 and -1, right? Now where do I go from there? What's my map tell me? Up 3. Right 1 to right here. And now I'm going to draw this line like that. So this is the graph of y equals 3x subtract 1. Now, I want the absolute value, which then means what? Well, if I take the absolute value of a number, what am I finding? I'm finding its positive distance from 0, right? But it's always going to be positive. So what actually happens in this graph then is once I've got this graph established, as soon as I hit the x-axis, everything below it is going to reflect above it because I can't have a negative y. Right here is -1. What's the absolute value of -1? 1. Absolute value of -2? -3? Okay, so we get the gist, right? So now I go to this point here and up, and it should go through 1. My board's off again, as usual. So what is it then? Okay, I have that. That blue is my absolute value of y equals the absolute value of 3x subtract 1. So as soon as you hit this axis, anything below it reflects up into the positive. All those negative y's become positive y's now. Okay? Here's the complicated part. All right? It's going to ask you to give the domain of this graph. All right? So the domain of this graph is what? What's the domain of y equals the absolute value of 3x subtract 1? No, domain. Domain. What? X is an element of all reals, right? Okay, it's a line that I just converted into this V shape, but it goes up and out forever. So that's your domain. What is my range though? Y is greater than or equal to 0, correct? Okay, I could describe how I drew this graph doing something else by explaining my domain. Because what I've basically done here is I've taken two graphs and made it one. Here's how this works. Okay, so just make sure I got my notation right. So here's f of x if. So no, I have to do this different. I'm gonna hold off on this for a second. What I'm gonna do is, what I'm gonna get to is, I'm going to take this positive part right here of this graph, and I'm gonna explain that in my domain, and then I'm gonna take this part of this graph and explain that as part of my domain. It's called piecewise. And we have to do this in grade 12. Okay? So they sort of tell you about this. If you look at page 285, it says y is equal to f of x if f of x is greater than or equal to 0, and negative f of x if f of x is less than 0. So what it basically says is that it's this, for this equation, if it's greater than 0, it's greater than this part, and then it's this if it's less than 0 down here. Okay? But we'll worry about piecewise in a little bit. I'm not gonna, that's probably gonna confuse you more than anything. Okay, so if you look at page 286, A says determine the y-intercept and the x-intercept. All right, what's the y-intercept of that graph right there? What is it? The new graph. The absolute value graph.
1.
No. What is it?
1.
1. Okay? It started as -1, right? When I graphed y equals 3x subtract 1, started here. But the moment I reflected it up, it went through this point right here. It's a terrible drawing, I know. Okay? But that's where it goes through. So the answer, the y-intercept is 1. Well, put 0 in for x here. Because that's where the y-intercept is, right? Put 0 in for x. 3 times 0 is?
0.
0 subtract 1 is?
1.
-1. The absolute value of -1 is?
1.
There's my y-intercept. Okay? Yeah.
Your negative one should not be +1. The blue one.
Right here?
Yeah.
No. No. That's this entire line right here.
Oh.
Okay, going backwards. Okay, we'll get to that in a second. Okay, I'll just leave this off. It's just going to confuse you for a second. Okay, so what's the x-intercept? How do I find the x-intercept? Yeah, very good. Make y equal to 0, right? Okay, now, this is the catch right here. Because this is 0, it's not going to matter. But realistically, to solve for this, I would go 0 is equal to 3x minus 1. And then I would go 0 is equal to negative 3x minus 1. Because the positive or the negative in here is still going to give me that. But for right now, because I'm using 0, I don't have a positive and a negative. So all it is 0 is equal to this. So what is x equal to? 1/3, which is that coordinate right here. There's your x-intercept. It says sketch the graph. We've done that. State the domain and range. We've done that. Express it as a piecewise function. That's the part I want to leave out for a minute until Monday. Okay? Let's look at the second example now. The second example, so that was an example for a linear function. Now what about when I have this? Y equals absolute value x squared minus 3x minus 4. Okay? So determine the y-intercept and the x-intercept of this one. All right, let's follow your book for a second. In A, so write this in your book as we go along. Determine the y-intercept by substituting x is equal to what?
0.
0, right. In the function it's solving for y. So I put 0 in, I get 0 squared minus 3 times 0 subtract 4, which is going to give me what? No. Minus 4, right? So I have this. So what does that equal? Minus 4, right? What's the absolute value of minus 4? plus 4. So the y-intercept is going to occur at 0 and 4. Okay? Determine the x-intercept by substituting y equals 0 into it. So my x-intercept then, the next page here, is 0 is equal to x squared minus 3x minus 4. How many x-intercepts am I probably going to have here? 2. So how do I get those x-intercepts? What do I do? What do I do? Factor it, right? What are the factors of x squared? X and x. What are the factors of negative 4 that add to give me negative 3?
Minus 4a.
Very good. Negative 4 adds 1. Okay? So what are my x-intercepts?
4 and 1.
4 and minus 1. Okay? So the x-intercepts occur at 4 and 0 and minus 1 and 0. Then it wants us to graph this. Okay? Now, this goes back 2 units now. Says that there's a way in which we can graph this using completing the square. Okay, so that would work. You can use your calculator for this section, so I'll show you that after. But where is my vertex going to occur? How do I find my vertex? What have I found here? Those are my roots, right? So where's my vertex going to occur? Halfway between. Exactly. So my x value of my vertex then is halfway between negative 1 and 4, which is what? What you got? 2.5. Is it 2.5? Okay. Halfway in between. All right. Add these two together and divide by 2. 4 plus negative 1 is 3. 3 over 2, right? So I have 3 over 2 here. Now I can substitute it into that equation to find out what y is. So I got 3 over 2 squared minus 3 times 3 over 2 minus 4 equals 9 over 4 minus 9 over 2, 2, minus 4, right? Common denominator, 4, so 9 over 4 minus 18 over 4 minus 16 over 4. So 9 minus 18 is negative 9, negative 9 and negative 16 is negative 25 over 4. So what's my vertex? There's my vertex, right? Okay. So my x value here, I solve for my y value by plugging it into the equation. I could have completed the square for this, right? Half the middle value is 3 over 2 squared, added to negative 4, negative 9 over 4. So we could have done that, all right? Or just punch it into your calculator and solve for it at this point. Okay, I'm not concerned about your ability to solve these anymore. We've done that already. What I'm concerned about is can you use your calculator to solve for the absolute value of this graph. So now, from this point, now that I've got my vertex, I'm going to graph it without my absolute value for a second and see what it looks like. Because I have my vertex. Right? 3 over 2, which is 1.5, right? And then down here is 2, 3, 4, 5, and 6. So it's about right here. So that's 3 over 2, and negative 25 over 4 is negative 6.25. Okay? I use my one here. 3, and 4 is over here, right? There's my roots. Solve for those bad boys right there, right? And then just draw it now. So there's my quadratic equation. Again, not testing on your ability to do the algebra here. Maybe the factoring, because we just finished working on factoring. All right? But you got to draw this. I now need to take the absolute value of this graph. Now need to take the absolute value of this graph. All right? What did we say? Look back in your answer, and what did we say the y-intercept was going to be? What is it? 4. So now I'm going to graph this part right here, this negative part, the bottom part. I need to reflect it into the positive now. Okay? So I'm going to take this up to right here. And there is the graph of the absolute value of x squared minus 3x minus 4. Okay? All right, take out your calculators right now, please.
Yeah.
Okay. Change your window. Yeah. Change your window on your calculator to minus 10, 10, 1, minus 10, 10, 1. Where's your graphing calculator? Go. You need one. Go to the library and get one.
I don't think they have them.
Yeah, they do. I just brought 3 new ones. Go get a calculator. Here, use this one. Okay, so change your window first to minus 10, 10, 1, minus 10, 10, 1. Okay? Then go y equals. Now, we have to find the absolute. Okay? So go to math. Is it on there? No. Just want to see what it is. Oh. It's under CPX. CPX. And that, hit enter. And then you can put. Okay?
What's the difference between that and the one under?
And the one Mark say?
There's a number.
Is there an absolute under number?
The first one under number, the fifth one under.
Okay, whatever. Punch it in. Same thing. Okay? So we go absolute, just kind of like what I did. I typed it in here. Absolute, x squared minus 3x minus 4. And then graph it.
Minus 4.
Let's put an upside down cat.
Did you get that? Anybody not get that?
I like your shirt.
Where I find absolute.
Math. Math. Math.
They're so complicated. Worst ever. I tried Taylor's one, I was like, yes. Taylor should have this is all the same color except she doesn't have this and she's got like a
Yeah.
design right here.
Same thing.
We're pretty much matching. Pretty much twin. Otherwise I had these pink ones with like lines through it. Not what I have. Pink ones with like lines through it.
Oh.
I like this one better. I also had one with all laces.
Using negatives.
And then I had memory foam ones. No, I don't have sunsets.
Okay, is there anybody else that wasn't able to get that
So
picture?
I need to put runners in this. I had salads, but after this spring sucks.
Okay,
Work.
anybody not able to do it? Those of you that just walked in, punch this in.